Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Purification and Characterization of Organic Compounds. Today, in this session, we are discussing one of the purification method of organic compounds, and that purification method is distillation. What is that? Distillation. So let's start the session. So distillation is an important method to separate volatile liquids from non-volatile impurities, right? Especially this distillation process is used to separate a volatile liquid from non-volatile impurities, right? So volatility, already we have discussed this. Volatile, what is the meaning of volatile liquid? Liquid that can be converted easily into vapor, can be easily vaporized, if it has to vaporize easily, it should possess more vapor pressure and less boiling point. Okay, so volatile liquid, here liquid having more vapor pressure and less boiling point. What is that? Boiling point is called as volatile liquid. So this volatile liquid, and it is associated with some non-volatile impurities. Non-volatile means which does not vaporize. Which does not vaporize are called as non-volatile. So volatile liquids and non-volatile impurities are present. Then you can separate them by the process called as distillation. And another liquids having sufficient difference in the boiling points. Okay, so you can separate two liquids. So distillation can be used to separate liquids having more difference in their boiling points. What is that? More difference. Normally said greater than 20 degrees. Greater than 20 degrees. More difference in their boiling points. Because why I am mentioning this 20 degrees is this is asked in the examination. If two liquids having boiling point difference greater than 20 degrees centigrade, more difference generally called. More than 20 degrees centigrade, they can be separated by distillation. Which is distillation? Simple distillation. What is this? Simple distillation. You can separate them by simple distillation. Okay. See here we are given an apparatus in which it shows the simple distillation process. So we are speaking about what? Simple distillation. Okay. In the simple distillation, you are finding round bottomed flask. RB flask means round bottom. Bottom must be round. Then it is called as a round bottomed flask. In this we are taking what? Two liquids whose boiling points differ by greater than 20 degrees centigrade. Okay. Now you are heating it. You are finding Bunsen burner. You are heating it. Okay. So what is this? Fire. Heating. On heating it, liquid with less boiling point evaporates. what happens? Less boiling point evaporates, and it is coming through this. Here, what is there? Condenser. When it is coming through this pipe, what is there? Condenser is there. Condenser means which cools apparatus, which which decreases the temperature. Okay, condensation, cooling. So when the vapors are coming through this tube, what happens? They get cooled up. When they get cooled, they get converted into liquid, and that liquid is collected in this liquid substance. So which liquid is this? Which liquid comes out first? Liquid with the less boiling point comes here. Liquid with the lesser boiling point. Who remains in this round bottom flask? Liquid with the more boiling point remains. So did you separate them? Yes, we have separated them. Liquid with less boiling point is separated from liquid with more boiling point simply by heating it. And such a distillation process is called as what? Simple distillation process, right? So simple distillation, the vapors of substance formed are condensed and liquid is collected in the conical flask. So in this conical flask, liquid is collected. Which liquid? The liquid with lesser boiling point. Okay. So this process is used for purification of liquids which does not undergo decomposition at their boiling point. So this point is important. This is examination point that can be asked in the statement type question. So what type of liquids can be purified by the process of simple distillation? Simple distillation. So we can purify the liquids which do not decompose. There are some liquids which decompose into another substance at their boiling points. But here we are speaking about the liquids which do not decompose at their boiling point. So first thing is you can purify the liquids which does not undergo decomposition. Undergoing decomposition means which breaks into another substance. So we want that substance. If it is breaking into another substance, how can you extract that substance? It's not possible, right? So the liquids which do not decompose at their boiling points can be purified by this simple distillation process. This point is important for examination. Next, the vaporization of liquid by heating. Now only we have seen that process. First you are heating it, then you are condensing the vapors. When you heat it, the liquid with less boiling point vaporizes, and when it is passing through the condenser, it gets condensed into liquid by cooling, is known as what? Distillation process. So this is distillation process. Heating, on heating, vapors of liquid having low boiling point are moving through the condenser, they get condensed and converted into liquid. That's called as what? Distillation process. So liquid mixture is taken in round bottom flask. This already we have seen, and heated carefully. The vapor component with lower boiling point. So this is important. Distills first. Distills first means vaporizes first. The vapors formed is condensed by using what? Whom? Condenser. And the liquid is collected in the receiver. The vapors of the component with higher boiling point distills later. Okay, so this is all the process in simple distillation. See, the liquids that have boiling point difference greater than generally 20 degrees centigrade can be purified by this method called as simple distillation. See here, boiling point 334, 457. So chloroform is having boiling point of 334, right? CH, Cl3, C6, H5, NH2, aniline. So this point is asked, this example is asked in P by Q. Okay. Next, here also you can see 308 Kelvin, 384. What is that? Ether, ROR, toluene or toluene. What is that? CH3 methyl benzene. Okay, and benzene 353 Kelvin and aniline 457 Kelvin. These two liquids can be separated by simple distillation because their boiling point difference is very huge. So this is asked in P by Q, previous examination. Propanol, CH3, CH2, CH2OH, propanol, propanone, CH3, C double bond O, CH3. What is this, sir? Ketone, propanone. 3 carbons are there. What is this? Propanol. Their boiling point difference is also more. 329, 370 Kelvin. So when the boiling point difference is huge, then automatically they can be separated by simple distillation. Generally saying that greater than 20 degrees centigrade difference can be separated by simple distillation. So benzene is a liquid whose boiling point is 353 Kelvin. Aniline, now only we have seen aniline is what? C6H5 NH2. What is this? Aniline. So as the boiling point differences are more, they can be separated by simple distillation. These examples, we need to remember the examples. In the examination, they focus on examples. Which compounds can be separated by which purification methods? That is important. So concentrate, more concentration on these examples is important. First of all, method, principle of that method, and examples. And among these three, which is more important is examples because they are asked more in the examination. Right? So let us move to the next part. That is about simple distillation. We are now seeing about fractional distillation. What process? Fractional distillation. Right? So what is the difference between simple distillation and fractional distillation? A very small difference. We are separating the liquids whose boiling point difference is less than 20 degrees centigrade. What is that? Boiling point difference is less than how much? 20 degrees centigrade. So it is used to, that means if their boiling points are very closer. What did you understand from that? If the boiling points of those two liquids are much closer, then those cannot be separated by simple distillation. They can be separated only by fractional distillation. So separating liquids, mixture of liquids or separating liquids whose boiling point difference is less than 20 degrees centigrade. Those can be separated by fractional distillation. So from childhood, that means from high school, we used to study that petroleum can be separated into different components by the process called as fractional distillation. Okay, so here is set up for fractional distillation apparatus which is showing a fractional distillation. The only difference between simple distillation and fractional distillation is this fractionating column. What is this, sir? Fractionating column. Before passing the vapors into the condenser, first of all, they are passed through a column, and that column is called as what? Fractionating column. Fractionating column. So here liquids are taken, liquid to be distilled is taken. That means a mixture of liquids are there here. We are heating this mixture of liquids by using oil bath. Oil bath means it is nothing but oil. Oil is there. First heat transfers into oil. From the oil, the heat transfer into liquid. heat transfer into liquid. Directly we are not heating. Okay. So now what happens? This mixture of liquids. Let us take liquid liquid A and liquid B. Liquid B. Or otherwise, let us go with example. Right? What are those? One is acetone and another is methyl alcohol. See, 330, 338. So boiling point difference is less than how much? 20 degrees centigrade. The difference is only 8 degrees centigrade or 8 Kelvin, right? So one is acetone and another is what is that? Methyl alcohol. One is acetone and another is methyl alcohol. So let us take A as acetone, B as what is that? Methyl alcohol. So both are liquids, liquid A and B. Now when you heat it, both vaporizes. What happens? Both get vaporized. Now both get vaporized. Why both get vaporized? Because the boiling point difference is very much less. Okay. So when you are heating, you cannot differentiate them because the difference in the boiling point is very less. So when you are heating, you find that first of all, no doubt about it, acetone vaporizes. When acetone starts vaporizing, because its boiling point is only 380, 330 and 338. Here their boiling points are 330 Kelvin and 338 Kelvin. What are these boiling points? At 330 Kelvin, which vaporizes? Acetone vaporizes. From 330 Kelvin to 338 Kelvin, it does not take much time to increase the temperature. So when acetone starts vaporizing, automatically after a few seconds, methyl alcohol also starts vaporizing. If both vaporizes and both are condensed, again in this you don't get separate liquids. You get both the liquids. In the conical flask, we get both the liquids. So to prevent that, what is used? A column is used, and that column is called as a what? Fractionating column. So by using this fractionating column, you can separate liquid A and B, whose boiling point difference is very much less. Understood? So what happens in the fractionating column? What is the process? We shall see. So fractional distillation is used if the difference in the boiling points of the two liquids is less than 20 degrees centigrade. Okay. Vapors of liquid mixture are passed through fractionating column before condensation, which is fitted over the mouth of the round bottom flask. So before coming to condenser, before condensation, first of all they are passed through fractionating column. Vapors of liquid with higher boiling point condenses before the vapors of liquid with lower boiling point. The vapors rising up in the fractionating column is rich in more volatile component. Okay, right? What are now taken? Two liquids. You are heating. So liquid A and B both are moving up. Liquid A and B both are moving up in this direction, in this way. When they are moving up, what happens is, you know that A is acetone, right? A is acetone and B, what did we take? Methyl alcohol. B is what? Methyl alcohol. Methyl alcohol. So among these two, which is more volatile? Acetone more volatile than methyl alcohol. What is that? Acetone more volatile than methyl alcohol. This is methyl alcohol. This is acetone. Acetone, methyl alcohol. Okay. So as acetone is more volatile, what happens when it is moving up in this fractionating column? You are finding two types of fractionating columns here. One is simple packed column, another is bubble plate column. You need to remember the structures also. Sometimes they can ask question directly on the structure. Which among the following is bubble plate column? Bubble plate fractionating column. Which among the following is simple packed fractionating column? They will ask in this way, right? So both A and B are moving up. When both A and B are moving up, it is found that as A is more volatile, it is not condensing. Condensing means getting cooled. So when these are moving up, they pass through this fractionating column. When they are passing through this fractionating column, see there is some equipment here. Here there is some equipment. Do you find some plates, some equipment is there? In this equipment, when A and B are moving up, there will be exchange of heat. Some heat is given to these plates because they are touching. When they are touching, some heat will be transferred. When heat is transferred, automatically both A and B get cooled. Cooled means not cooling, their temperature decreases. When their temperature decreases, automatically what happens? They get condensed. They get condensed. Among A and B, which will condense first? If they get condensed, if their temperature decreases, slowly they will be converting into liquid form. So which converts into liquid form first? B converts into liquid form first. So the vapors of methyl alcohol condenses first and return to the round bottom flask. So what is happening when both liquids vapors are moving in this fractionating column? The one which is having a higher boiling point will condense first. Why it is condensing? Because there is exchange of heat in this fractionating column. Why there is exchange of heat? There is some equipment. When these vapors are touching that equipment, automatically they transfer heat. They will lose heat. When they lose heat, which condenses first among methyl alcohol and acetone? Methyl alcohol will condense first. When it condenses first, it get converted into liquid and falls into the round bottomed flask. Whereas acetone, it is not condensing easily because its boiling point is less, so it slowly moves up. So this process happens. There is exchange of heat happening. There is exchange of heat happening. So condensation and vaporization occurs, right? So vapors of liquid with higher boiling point condense before the vapors of liquid with a lower boiling point. Lower boiling point will not condense earlier, but vapors with a higher boiling point is methyl alcohol here. So the vapors rising up in the fractionating column will be richer in more volatile compound. So these vapors are slowly moving up, right? So these vapors will be of more volatile liquid. So among this acetone and methyl alcohol, which is more volatile? Acetone. The one which is having less boiling point is more volatile. More volatile is acetone. So at the upper portion, at the top, see here fractionating column you are taking, at here top, when you are continuously heating, First of all, here at the top, you will find vapors of whom? Vapors of low boiling point liquid. So this low boiling point liquid vapors comes here first, and they will be moving. They get condensed, and you will get here liquid. As it is condensed here, it get converted into liquid and collected in this conical flask. What is that? Conical flask, and you will find here liquid. Liquid with which liquid? Liquid with less boiling point. Which liquid here? This is acetone. Acetone is having a less boiling point, so you will get a liquid, acetone liquid here. Okay. Now, when you are heating the mixture of liquids in the round bottom flask, they get vaporized. Then moving through the fractional column, they get condensed. Again, they come to they convert into liquid. Again, they get vaporized, condensed, vaporized, condensed. So this process will be repeating in this fractionating column. So each successive condensation and vaporization unit in the fractionating column is called as theoretical plate. So there is a different word term used here. So that is important here. For the purpose of understanding, let us take here, this is a theoretical plate. Theoretical plate. What is this theoretical plate? At this theoretical plate, one condensation and one vaporization occurs. One condensation, theoretical plate, one condensation and one vaporization occurs. See, each successive condensation and vaporization unit. So this is a unit at which one condensation and one vaporization occurs in the fractionating column, and that is called as what? A theoretical plate, for the purpose of understanding, right? So fractionating column provides many surfaces for heat exchange between ascending vapors and descending vapor, condensed liquid, vapors and descending condensed liquid. So here this fractionating column is providing lot of surface. Here also you are finding glass beads. You see glass beads. When they are glass beads, so when these vapors are ascending, moving up, when they are moving up, they exchange heat with the glass beads. Okay, they exchange heat with the glass beads. So when they exchange heat with the glass beads, vapor loses some heat. When vapors lose some heat, they will be converted into liquid. So when they convert into liquid, again they come down. What happens? They move down. So this is a continuous process. Vapors are moving up. Vapors with low boiling point will be moving up. Vapors with more boiling point will be condensed first, moving down. So this is a continuous process happening in the fractionating column. So overall, what you find? You will find that which vapors comes out first. Vapors of the liquid with less boiling point comes out first in the fractionating column, from the fractionating column, and get condensed and convert into liquid, and that can be separated. Are you getting this? So the only difference between a simple distillation and fractional distillation is what? Fractionating column. Two types of fractionating columns are given in our syllabus. What are those? Simple packed fractionating column and bubble plate fractionating column. And there are different many units in this fractionating column. Each unit is called as theoretical plates, where one condensation and one vaporization occurs, right? So the best example we have seen already. What is that? Methyl alcohol and acetone, which whose boiling point difference is less, that can be separated by fractional distillation. And the fractional distillation is more widely used to separate different fractions of crude oil in petroleum industry. Okay, in petroleum industry, the crude oil is called as petroleum. Petroleum is a mixture of different hydrocarbons. Those hydrocarbons can be separated by the process called as fractional distillation, because those different hydrocarbons boiling point difference is very much less, right? So that is about fractionating column. Let us move to the next. Next distillation process is what? Distillation under reduced pressure, which is also called as a vacuum distillation. Distillation under reduced pressure. Okay. So when you decrease the pressure over the liquid, the boiling point decreases. Boiling point decreases. So we have studied that here. Let us take a liquid. Let us take a liquid. So this liquid, this liquid is exposed to the air. Air pressure is how much? Atmospheric pressure 1 atmospheric 1 atm. 1 atm is what? Atmospheric pressure on the surface of the earth, sea level surface. Atmospheric pressure. Atmospheric pressure. Okay. So now, what is the boiling point of this liquid called? What is the boiling point? So boiling point means it is the temperature at which the vapor pressure of the liquid is equal to atmospheric pressure. Okay. Boiling point means it is temperature at which the vapor pressure of liquid equals atmospheric pressure. Vapor pressure of liquid equals atmospheric pressure, and that is called as what? Boiling point. We know boiling point of water is? Boiling point of water is 100 degrees centigrade at 1 atmospheric pressure. If you decrease the pressure, boiling point automatically decreases. So boiling point of liquid decreases on decreasing pressure over the liquid. So this you need to remember. What you need to remember? If you increase the pressure over the liquid, boiling point increases. It's pressing, pushing. So when it is pushing the liquid with more pressure, the liquid cannot be boiled at low temperature. More temperature is required to boil it. If the pushing pressure is less, then the liquid can be boiled at low temperature. So simply understanding, if you increase the pressure over the water or over the liquid boiling point, what happens? Increases. If you decrease the pressure, the boiling point decreases. Understood? So distillation under reduced pressure, that means you are decreasing the pressure over the liquid. You can decrease that pressure over the liquid by using vacuum pump. See here, one instrument is used to decrease the pressure. What is that? Vacuum pump. In our homes, we use vacuum cleaners. Vacuum cleaner creates vacuum so that the dust enters into that space where vacuum is created. So there is a vacuum pump by which you can reduce the pressure over the liquid, right? So which type of liquids are purified or separated by using this vacuum distillation. So distillation under reduced pressure. A liquid boils at temperature below its vapor pressure by reducing the pressure. By reducing the pressure, the liquid will boil at low temperature than its boiling point. By reducing the pressure over the liquid will boil, or boiling means it will get converted into vapor form below its boiling point. Below its boiling point. That means its boiling point decreases, simple thing. So here this method is to purify liquids having high boiling points which decomposes at or below their boiling points. So this point is very, very much important. So there are some substances which decompose at their boiling point. If you heat them, they will decompose at their boiling point. Okay. For example, let us take there is a liquid. There is a liquid. So this liquid boiling point is something like 80 degrees centigrade. If you heat it up to 80 degrees centigrade, it is found that liquid is decomposed. Liquid is decomposed. Decomposed means it is converting into another substance. It is breaking into another substance. But we don't want that substance to be broken into another substance. We want that liquid, pure liquid, in the vapor form. So for that purpose, what happens now? Over this liquid, you are decreasing the pressure. Decreasing pressure means removing air over the liquid. So on decreasing pressure, boiling point decreases. So that what happens? So that liquid vaporizes or boils, vaporizes below its boiling point. Below its boiling point, it vaporizes. Now it is not reaching the boiling point. If it reaches the boiling point, it decomposes. If it does not reach the boiling point, it does not decompose. So it is vaporizing. So that is the fetching of this distillation under reduced pressure. When you decrease the pressure over the liquid will vaporize below its boiling point so that it will not decompose. So that this point is important. So these liquids are made to boil at temperature lower than their normal boiling point by reducing pressure on their surface. On their surface, we are reducing the pressure. On the surface of the liquid, we are reducing the pressure so that they will boil below their boiling points. Okay. Next, the pressure is reduced with the help of vacuum pump. So this point is very, very much important. Several times this point is asked. What is that? Glycerol can be separated from spent lye. See, lye means NaOH. Okay. See, NaOH is used in soap industry. NaOH is used in the soap industry to manufacture the soap. After completion of soap making, some of the NaOH is left. Some of the NaOH remains without reacting. And along with the spent lye, some glycerol will also be produced. Glycerol will also be produced. So now what is there here? In this mixture, we have, right? We have glycerol. What do we have? Glycerol. And we have spent lye. Spent lye means spent NaOH. NaOH and glycerol. Now we have to separate these two liquids. These two liquids can be separated by the process called as what? Distillation under, what is that process? Distillation under reduced pressure. Distillation under reduced pressure or vacuum distillation. reduced pressure. Right? So when you decrease the pressure over this liquid, glycerol will boil below its boiling point. If you don't reduce the pressure and if you distill, glycerol will decompose. Glycerol, what happens to glycerol? Glycerol will decompose. If you decrease the pressure over this liquid mixture and heat it, the glycerol will be boiled below its boiling point and can be separated. Distillation, anyway, you know what is meant by distillation already. We have discussed the simple distillation, fractional distillation, heating, vaporizing. Especially here, distillation under reduced pressure, which is also called as vacuum distillation, is used to prevent the decomposition of that substance, because some substances decompose when they are heated up to their boiling point. Understood? Right? So this point is very much important. Glycerol can be separated from spent lye in soap industry by using what? Vacuum distillation. So let us see the next distillation process. The next distillation process is what? Steam distillation. What we are discussing? Steam distillation, right? Steam distillation. Okay. In the steam distillation, what do you do? There are some compounds whose boiling points are less. Some compounds, organic compounds, are steam volatile. Steam volatile. Steam volatile means they evaporate along with steam, along with water vapor. Okay, vaporizes along with steam. Those are called as the steam volatile. Vaporizes along with the steam, and those are called as what? Steam volatile. Okay. Already we know that volatile liquid means what? Having less boiling point. So these liquids have less boiling point. They have less boiling point. Okay. Now let us see the apparatus given for the purification by steam distillation. Here is water. You are heating water. The water is converted into water vapors. They are water vapors. They are moving through this. Here you are having the compound which is to be separated or distillated. The compound that is to be distillated. So now the steam comes into this. Steam is having high temperature. Okay. So along with the steam, the compound will be, now who will vaporize? Now you will find vapors here. You will find vapors. Whose vapors are these? These two vapors. So if you find here, you will find vapors of water and vapors of the organic compound. Vapors of water and organic compound are here. So both vapors are made to move through the condenser, and finally what you get? So you are getting water. What is this? This layer is water. This upper layer is water, and this lower layer is water, organic compound. Organic compound. Okay. So this steam distillation is used to purify the organic compound which is steam volatile. Which is a steam volatile. Okay. Which vaporizes along with the steam. Now, in this flask, we find vapors of what and what? Vapors of water and organic compound. Vapor means when does a liquid convert into vapor? Now only we have seen at its boiling point. At its boiling point. So now this vapor is a mixture of vapors of water and vapors of organic compound in liquid form. Okay. Now what you are doing, both vapors are there. Now I can write that atmospheric pressure is equal to vapor pressure of water plus vapor pressure of liquid, that is organic compound. Let us take it as P. P is equal to P1 plus P2. Okay. Mostly vapor pressure is 760 mm, right? 760 mm on the surface of the earth. So P1 will be approximately vapors of water vapor. It will be nearly 750, and this P2 will be approximately, this is also speaking about approximately, okay, 10 mm. So liquid is vaporizing at just 10 mm, as liquid, which is organic compound, is vaporizing at 10 mm of Hg, which is less than atmospheric pressure. It will not decompose. There is no possibility of, because some compounds, already we have discussed that some organic compounds will decompose at their boiling point. Now this liquid, is it reaching to boiling point? No. If it has to reach its boiling point, its vapor pressure must be equal to 760. Just at 10 mm, it is vaporizing. It is vaporizing at very less temperature. Okay. This is Dalton's law of partial pressure we are using here. Total pressure is equal to vapor pressures of individual substances. See here, this method is used for separation and purification of organic compounds, solids or liquids, which are steam volatile. We are purifying or separating the liquids which are steam volatile. And another is insoluble in water. If they are soluble in water, you don't get two layers here. One is layer 1. This is layer 2. Two layers. Again, these can be separated by using separating funnel. After the formation of two layers, before in previous lecture we have studied how to separate. Here separating funnel will be there. So liquid layer, that is water layer, and organic compound liquid layer can be separated by separating funnel. What is that? Separating funnel. Okay. So this organic compound must not be soluble in water. It must be insoluble in water. Conditions for the liquid to be distillated by steam distillation. One condition is that the liquid must be steam volatile. Another condition is that it should not be soluble in water and it should have non-volatile impurities. So non-volatile impurities means though you are heating, they should not get converted into vapor. So they remain here. Are you finding in this? I'm drawing this. Okay. So non-volatile impurity. What is that? A non-volatile impurity. Non-volatile means which cannot be converted into vapor. So steam distillation is based on the Dalton's law of partial pressure, where P is equal to P1 plus P2, where P is atmospheric pressure. Now only we have seen P1 vapor pressure of organic liquid, P2 vapor pressure of due to water. So this point is very much important. What is that? The organic liquid vaporizes at low temperature than its boiling point. It can be asked as a statement type of questions. What is that? In which process the organic compound is vaporizing at lower temperature than its boiling point? This is one of the process. In vacuum distillation also, the liquid vaporizes below its boiling point. Here also, the liquid is vaporizing very much below its boiling point because already the remaining vapor pressure is accomplished by water vapor. Okay. Next, this mixture of water and organic substance obtained can be separated by what? Separating funnel. Now only we have seen separating funnel. Liquid and organic compound layer can be separated by using separating funnel. So compounds which can be purified by this distillation, steam distillation, are aniline, nitrobenzene, orthonitrophenol, orthohydroxybenzaldehyde. Okay. So aniline, right? So this is aniline. Nitrobenzene, so this is nitrobenzene. Orthonitrophenol, right? So orthonitrophenol. So in this orthonitrophenol, this is the structure of orthonitrophenol. This is orthonitrophenol. In this orthonitrophenol, there is intramolecular hydrogen bond. Intramolecular hydrogen bond. As there is intramolecular hydrogen bonding, its boiling point is less. What you need to remember, it's P by Q. You need to understand this. Okay. So here is OH. 1, if you take 1 as this position, this becomes 2 position, which is also called as ortho. At ortho position, we have nitro group, NO2, and benzene with OH is called as phenol, orthonitrophenol. Here you find intramolecular. In the same molecule between different atoms, we have hydrogen bonding. Hydrogen bonding is represented in the form of dots. So due to this intramolecular hydrogen bonding, orthonitrophenol has a less boiling point. And this due to this less boiling point, orthonitrophenol is found to be steam volatile. Steam volatile. You will be asked a question called as orthonitrophenol and paranitrophenol can be separated by. This is what paranitrophenol. So the question is that orthonitrophenol and paranitrophenol, here is P by Q, previously asked. Ortho means O, right? We write it as orthonitrophenol and paranitrophenol can be separated by what process? Steam distillation. So who undergoes steam distillation here? Orthonitrophenol, due to its less boiling point, it is steam volatile. Orthonitrophenol is steam volatile due to intramolecular hydrogen bonding. Intramolecular hydrogen bonding present in it. Okay. So this point is very important. And another can be purified and separated. Here purified orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. This is benzaldehyde. This is orthohydroxy. Orthohydroxybenzaldehyde. So why we are writing these structures and all these? But to remember, once you look into that, you may be remembering those, because the examples or the compounds which are separated by different methods, those examples, which compounds are separated by which methods is important, because that is mainly asked in the competitive examinations. Understood? Right? That is about different types of distillations. We discussed about 4 types of distillation. What is simple distillation? Next is fractional distillation. The third one is distillation under reduced pressure, or which is also called as vacuum distillation, and the fourth one is steam distillation. Right? So this is all with the distillation process. This is all with this session. Let us wind up this session, and in the next session we shall discuss the remaining part of purification methods. Thank you very much for watching.